Okay, so today we're going to do the perm check from lesson 4 of counting elements. The perm check question, algorithmic question. So here's the question, I'll read it out before we start. A non-empty array A consists of n integers is given. A permutation is a sequence containing an element from 1 to n once, and only once. For example, an array A such that A of 0 is equal to 4, A of 1 is equal to 1, A of 2 is equal to 3, and A of 3 is equal to 2 is a permutation. But an array A such that A of 0 is equal to 4, A of 1 is equal to 1, A of 2 is equal to 3 is not a permutation because the value 2 is missing. Because if we were to count the elements in the array, it doesn't have it in sequence from 1 to 4. It skips over 2, and any permutation must be a sequence when arranged of consecutive numbers. The goal is to check whether array A is a permutation. Write a function that, given an array, returns 1 if A is a permutation and 0 if it is not. For example, given array A such that A of 0 is equal to 4, A of 1 is equal to 1, A of 2 is equal to 3, A of 3 is equal to 2, the function should return 1. Given an array A such that A of 0 is equal to 4, A of 1 is equal to 1, A of 2 is equal to 3, the function should return 0. Write an efficient algorithm for the following assumptions. N is an integer within the range of 1 to 100,000, and each element of array A is an integer within the range of 1 to 1 billion. Okay, let's start. Okay, so we know we're looking for permutation. So let's think now. What do we know given an array? A is the array we need to check for whether it is a permutation or not. Okay, so the first thing we know is that the maximum number that the array should reach, A max, the numbers contained within A, the numbers contained within A should be from 1 to So if we look at the array that we got that was a permutation, it went from 1 to the array's length, right? So we have an array of with 4 elements, so it's 1 till A dot length. So that's the two factors that we know. Now we have to think of an efficient way in order to determine whether it is an array or not. So off the top of my head, one thing I could think of doing is potential solutions. We can sort the array, and then if any number is skipped, it is not a permutation. That is one potential method. 2. We can use a hash table, I think. Right? I really want to use a hash table, but I'm not sure if we could use it in this situation. Can we? So we can sort, and then we can loop and count and make sure that A is always equal to A plus 1. So let's actually start with the potential solution number 1. I don't think this will be an optimal solution, but sort array check if all numbers are consecutive. Okay, so this is going to be our brute force solution. Okay, so we get our array, we're going to sort it. Boom. So now for I is equal to let I equal 0, I is less than a dot length, I plus plus, right? Let's just start off at 1. Okay, so if a of I minus 1 is not equal to a of I minus 1, actually we don't even need to do that. So I is equal to 0. So if a of I, because it always starts at 1, right? So if a of I is not equal to I plus 1, return 0. Else, outside the loop, if it was able to get through everything without being scathed, return 1. Okay, so this is the simplest solution, but I don't think it's the optimal solution. Right? So let's submit the task, and I'm pretty sure that it'll complain about speed. So we got a 75, and we actually didn't get total correctness. So let's see where the test cases failed. So it said permutation of sets like 2 to 100 for which the answer should be false. Got a 0, expected a 1. So even if the permutation doesn't start off at 1, it is still a permutation. Okay, so that's interesting. And large sequences, got a 0, expected a 1. All sequences are permutations. Okay, so in part 2 we will try solving this in the correct way. So we had a couple of issues with this potential solution.